We all know that SolarEdge systems produce more energy than other technology. But how much more? Well, we tried to answer that question here in Australia over the last 18 months by doing an extensive study of over 500 SolarEdge systems in Australia. Simple systems that were easy to then compare to how they would perform on string systems. And the answer was a shocking 6 to 10% more energy over the life of the system. Now that's a huge amount of additional energy being produced by SolarEdge. How do we do this? Well, it starts at the roof. On a typical string inverter, you have a central tracker dealing with a group of panels. Now those panels are all going to be performing slightly differently, and that means that it's trying to average out to find the sweet spot to extract the maximum power from a group of panels and averaging out the differences between them. That means that there's always going to be loss in the comparison of finding that sweet spot of performance between that group of panels. When we compare that to SolarEdge, we now have a tracker on every panel. That means that we can harvest the maximum amount of DC being produced by every individual panel without any waste. But it doesn't stop there. As we move down onto the ground, we then have major advantages as well, due to the fixed string voltage connecting the optimizers with the inverter. On a typical string inverter, as the voltage throughout the day moves around, the peak efficiency is going to be 92 to 96% at best. Whereas by controlling the voltage on the roof on string, a SolarEdge system is pinned, sitting at 99% efficiency from sunrise to sunset. So between those two crucial points, more from every panel and more from in the inverter, that's where we get our additional 6 to 10% more energy. But it doesn't stop there. Controlling the voltage also gives us an expandable system. The optimizers, by controlling that voltage, means that we can oversize our system long term and harvest the DC energy on the DC bus architecture. If you were to put 15 kilowatts of panels on a 5 kilowatt inverter, it would probably start to smoke typically with a string inverter. But with SolarEdge, we have no problems doing this. We could start with a typical solar system, but then come back to that customer in a few years' time to add some batteries and some more panels. Or in a few years' time further down the track, we might add a DC-DC EV charger and some more panels as well. 15 kilowatts of panels to charge all of these batteries would not be out of the question, but there's no reason to replace that 5 kilowatt inverter that you started with. Now, the reason this works is because the energy can flow seamlessly from the optimizers and the panels directly into our storage. As you can see here, the blue area represents the inverter output, and anything above the blue inverter rating, that peak energy can be harvested into our storage and then used at night. Crucially, this means that we can store energy from the roof without impacting on supporting our loads on the AC side. So we can support DC storage and AC loads at the same time without any bottlenecks. This is a phenomenal advantage to the SolarEdge optimized ecosystem. If we take it a step further and start looking at string hybrids, a typical string hybrid might have a round trip efficiency of close to 87%. Whereas with SolarEdge, if we're going from the roof out to the grid, we're close to 98% efficient, and through the battery, around 93% efficient. That's a significant difference and a massive loss of energy on the string hybrid. If we look at this over the year, you can see 36.5 kilowatt hours of usable energy from the string hybrid on any given average day. Whereas with the SolarEdge system, we have over 40 kilowatt hours per day, which is close to 30 to 40 extra days of battery use in any given year from SolarEdge over the string hybrid. Expandability is great, but it's only of use if you have versatility of where you're then putting your future panels. With SolarEdge, by controlling the DC, we can parallel strings of uneven lengths, and we can run strings around multiple orientations. We can also mix and match panels over the life of the system, and importantly, mix and match optimizers over the life of the system too, giving you the ultimate in flexibility to manage the roof over the 25-year life of the system. Another major advantage of controlling the roof means that we can make it safe. Typical string systems have uncontrolled voltage on the roof, anywhere from 600 to 1000 volts when the sun is shining, which is incredibly high potential to do damage to properties and people. Even with microinverter systems, you still run the risk of 240 volt AC on the property. Whereas with SolarEdge on the roof, during a crisis or during install, we lock down those panels to 1 volt DC, which makes everything safe to touch. 18 panels on a string, it's like holding 2 9-volt batteries. No one's going to be hurt. So when life throws you a curveball, whether it be a crisis with floods or hail damage, you know that you're not going to get a rooftop fire. We also have less points of failure on a SolarEdge system because of the redundancies in our system. When we look at a SolarEdge system versus a string system here, what happens if a panel goes down? Well, you completely lose the output of the string system, whereas with SolarEdge we have that independence. One panel gets damaged, it doesn't affect its neighbors. So in summary, homes are always going to need more energy into the future. But with a SolarEdge system, we deliver more energy from every panel and from the inverter down on the ground. But we also have those added benefits of safety, versatility, and visibility. And this is why we're increasingly the choice for MLPE in Australia.